Okay, so we're doing section 4 today out of chapter 8. I know this won't be quite as long as the previous videos, and actually I think this is quite a bit easier. The number one thing that is important for you to understand out of this section is how to factor. Factoring does come from earlier chapters, comes from Algebra 1 and earlier in Algebra 2. If you are struggling to factor, you're going to struggle with this. This is a perfect chance for us, though, to get some more practice with factoring. It is one thing that you should be able to do, and you should be able to do it quickly. So hopefully going through this, you'll get a better sense of doing it. You may not learn it again, but it'll give you a chance to practice some. So let's quickly go through a couple of definitions. What we're dealing with here is we're dealing with rational expressions. So when we were graphing in sections 2 and 3, we had a function on top and a function on the bottom, essentially. And that's what we're dealing with again here. But now what's going to happen is we're going to have functions that actually start to cancel out. So we're going to say that a rational expression is in simplest form if its numerator and denominator have no more common factors other than plus or minus 1. Okay, and then the reciprocal, that's our other definition. We've seen this before. Or multiplicative inverse of any non-zero number, b is 1 over b. Okay, and that is important when we divide. So right now we're going to talk about multiplying rational expressions. And what you're going to see is that sometimes we're not really multiplying them as much as we're just simplifying them. So I will let you read through this on your own, but essentially it's talking about how things can cancel out. And we've talked about this. If you have a 3 on the top and a 3 on the bottom, you can cancel them out. Well, the same thing is true if you have x plus 1 on the top and x plus 1 on the bottom. They can cancel out. It doesn't change. So let's look at an example here. So this first example, it's already written out for you. We have x squared plus 7x. The basic idea of this is we're always going to factor both top and bottom as much as we possibly can, so then we can cancel out and see what we're left with. So this first one, we factor out an x. There's an x here, there's an x here, so therefore there's an x on the outside. So we're left with x plus 7 on the inside. On the bottom, because it's x squared, you can factor that out as x times x. So what happens is an x on the top and an x on the bottom cancel out, so we're just left with the x plus 7 and then the 1x. Okay, so that's a pretty basic one. So let's look at a different example. So again, we have two quadratics, one on top, one on bottom. The first thing you notice they do is they factor the top, which is x plus 3 and x minus 5. Again, when you're factoring, the first and first have to multiply to be the first. The last and last have to multiply to be the last. And then you need to make sure that they add up to be what's in the middle, especially when it's just x squared. So in this case, factors of negative 15 are 3 and negative 5, and 3 plus negative 5 equal negative 2. And again, we're foiling this to make sure that the middle term is the same. But the shortcut, because it's only an x squared, okay, if there's nothing in front of your x squared, then we know that these two numbers have to add up to be the middle number. So that's the quick review you have on factoring. So once we get x plus 3, x minus 5, our bottom one is a difference of squares, x plus 3, x minus 3. What we do is we cancel out the x plus 3's. Whatever's on the top and on the bottom, we can cancel out. So all we're left with is whatever's left over there, and that cannot be simplified anymore. One thing you have to be very, very, very careful about is do not cancel out your x's there. You cannot cancel out the x's there. That doesn't work. The reason is because when you write a fraction like this, you basically are writing this with parentheses on both top and bottom. So because there's parentheses on both top and bottom, we can't cancel anything out because the minus 5 and the minus 3 would have to be done first. So do not cancel out the x's. Perfect example of this is this example right here. 4 minus 3 over 4 minus 2. I hope that you guys would not say this is not equal to negative 3 over negative 2. Okay? It's 4 minus 3, which is 1. 4 minus 2, which is 2. The answer is 1/2. This does not give you 1/2. You cannot cancel out your 4's. Okay? So make sure we don't make those mistakes. All right, what I want you guys to do, briefly, okay, go through and do these 4 examples on your own. They should be fairly quick. The first one's pretty easy. You don't even have to factor anything out. For 2, 3, and 4, I want you to factor them completely first and then cancel out. Really, this is a practice of factoring. So go ahead and hit play when you guys are ready. All right, so in this first example, you see there's no factoring necessary. You have an x plus 7 on top. You have an x plus 7 on the bottom. Those two will cancel out, and then all you're left with is x plus 9 over x minus 9. If it can't be factored or if the factors are not the same, do not cancel them out. Okay, next one down. X plus 4, x minus 5, x squared plus 4x minus 5 factors to x plus 5, x minus 1. The bottom, x squared minus 25, again, difference of squares is x plus 5, x minus 5. The x plus 5s cancel out, so you're left with x minus 1 over x minus 5. Next one, we have top one factors to be x plus 11, x minus 1. Bottom one factors to be x plus 8, x minus 1. The x minus 1s cancel out. You're left with x plus 11 over x plus 8. And then the last one, and these ones always seem to be the toughest ones for you guys to factor. We factor out an x. There's an x on both terms. Okay, so this isn't a factor with two binomials. This is just simply factoring out a common factor, which is x. So you bring x to the outside. That leaves us with x plus 4 on the inside. Again, you check that by multiplying. X times x is x squared. X times 4 is 4x. And then the bottom factor is x minus 6 times x plus 4. The x plus 4's cancel out, so we are left with x over x minus 6. And again, nothing cancels out after that. Okay, so let's move on. Okay, it gets a little bit more complicated, but not really. I mean, if when you see this, it's a little bit longer, takes a little bit longer, but really all we're doing here is we're multiplying now. So before we didn't multiply, we just factored and eliminated things. So what we're going to do is we're going to take two separate equations and we're just going to multiply them together. The thing is we've done problems like this before. We've already done that this year. Okay, that's from previous chapters, previous sections. Okay, so the idea is exactly the same, but here's what we're going to do. So let's look at this example right here. We always, 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 always factor everything first. So you always want to factor first. In other words, factor this, factor this, factor this, and then factor this if they can be factored. And then we will multiply at the end. So you notice the 3x minus 3x squared factors to 3x times 1 minus x. Or it could be a positive x minus 1. That's okay. Don't worry about that. So here's the deal. We factor each one separately. And then what we do is we combine them. Remember, multiplying fractions, we're just multiplying straight across. And you don't need to FOIL. You don't need to do any of that. All you need to do is put everything on one line so it's easier to cancel things out. Now, you can kind of ignore this right here because, honestly, if I were to factor this, it would have been, I would first rewrite it as 3x squared plus 3x. To me, this is easier. And then we bring out a negative 3x to the outside, and we're left with x plus 1 on the inside. But what they did is they factored it like this. They pulled the 3x out, and they left 1 minus x on the inside. And then what they do is they pull a negative 1 out. That's important. So they pull the negative 1 out to make it x minus 1. If I pull a negative out, it turns the 1 into a negative, it turns the x into a positive, and it turns out exactly like this. So then the x minus 1s cancel out, the x plus 5s cancel out, the 3x's cancel out, and then we are just simply left with x minus 4 in their case, but because they had the negative 1 there, it ends up being x plus, or negative x plus 4, or the same thing as 4 minus x. Okay, so theirs is a little bit different. If you would have done it this way, it should turn out okay. We're just going to end up with a negative in a different spot. Okay, so let's look at one that we're actually doing step by step. Again, these ideas are pretty similar. Factor, 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 don't need to factor, and then multiply and then cancel out. So here we go. 2x squared plus 4x. Factor that. We're going to pull out a 2x And what we're left with on the inside is x plus 2. Factor the bottom, we're left with x minus 6 and x plus 2. Over on the right, we have x minus 3 and x minus 6. And on the bottom, we still have 2x. Now again, you could go through and start canceling things out, but I just think it's easier to multiply everything first just to make sure we don't make any mistakes. So what I do is I do anything without a parentheses, I always put out front. So we have 2x, then we have x plus 2, x minus 3, and x minus 6. And on the bottom, I put the 2x out front, and then I do x minus 6 and x plus 2. And then what I do is I cancel out what we can. 2x's cancel out, the x plus 2 cancels out, and the x minus 6 cancels out. The only thing we are left with is x minus 3. Okay, so again, factor first, then combine everything, all the top on top, all the bottom combine on bottom, and then cancel out what you can, and then whatever you're left over with is your answer. So go ahead and hit pause, do these two problems on your own, and hit play when you're ready. Okay, so for this one, again, it's already factored for you. You just need to combine it into 1. So we have 5x and then multiplied by x minus 2 and x plus 1 on top, and then we put the 10 out front and then all 4 factors on the bottom. The only thing difficult about this one is the 5 over 10. We need to make sure we reduce that to 1/2. Okay, so that should be 1 over 2. The x minus 2 and x plus 1 canceled out, so all we were left with was x minus 6 and x minus 1 on the bottom. Make sure that if there's nothing left on the top, nothing, then it's going to just be 1. Okay, so that should actually be 1, and actually there's one problem with that. That should be 1x, I'm sorry. So it's 1x on top, and we have 2 times x minus 6 times x minus 1 on the bottom. Okay, so the bottom one, we have factor each one of these separately, so you have factors all the way through. Okay, check those factors. I'm not going to go through and explain how we got those factors, but once we combine everything on top and everything on bottom, the x minus 5, x plus 4, and x plus 2 all cancel out, and we're left with x minus 4 over x plus 7. Okay, so moving on to the last thing we have to cover. We're going to rush through this pretty quick because it's easy. Nothing changes about what we're doing here. This is now division. Now, if we're dividing rational functions, you'll see through this. It's the same exact thing as we did before, but we need to make sure that when you're dividing rational functions, all you're doing is multiplying by the reciprocal. It's just like fractions. If I said 1/2 divided by 2/3, we would say 1/2 times 3 over 2. All we're doing is taking the reciprocal of 2/3 and multiplying. Same thing here. And then we go through the exact same process. So I'll let you look through that one on your own. Let's do this one though. So we have 3 over x plus 7 divided by 8x squared minus 8x over x squared plus 6x minus 7. All we're doing is flipping this. So now it'll be x squared plus 6x minus 7 on top and 8x squared minus 8x on the bottom. So then we just go through and do the problem the exact same way that we did before. So this will end up being x plus 7, x minus 1. The bottom one, we factor out an 8x. So that's 8x on the outside and x minus 1 on the inside. So then what happens is we can cancel out what is similar. So the x plus 7 cancels out and the x minus 1s cancel out. So we're left with 3 on the top, 8x on the bottom. So 3 over 8x. Exact same thing. You just need to make sure that you multiply by the reciprocal when you're dividing. So pay attention to what the sign is. Okay, do these two on your own. Hit play when you're ready. Okay, so on this first one, we multiply by the reciprocal, so we flip this one. We multiply across the top first, so we have 10x to the 5th, y to the 4th. On the bottom, we have 18x to the 3rd, y to the 3rd. Simplified, 10 over 18 is 5 over 9. X to the 5th over x to the 3rd is x squared, and y to the 4th over y to the 3rd. Last one, multiply by the reciprocal, factor completely. We have no time left take a look at this, make sure you understand it. We'll talk about it more tomorrow if needed.